What we need to talk about are graphs of functions, how those graphs of functions, what they turn out looking like. Well, let me just start with a couple of graphs of functions. We'll talk about different ways we can graph functions, but let's just start with f of x equals 2x minus 5. F of x equals 2x minus 5. Hopefully, you recognize that function right there. We called it y equals 2x minus 5. Remember, f of x is just, now it's a replacement, a different way that we can talk about y values, f of x, y equals f of x. So this is the same, this would have, I'm talking about the graph of this here. This would have the same graph as y equals 2x minus 5, because f of x is now what we're calling the y value, given it a name of our function. Yeah, y equals 2x. What do we know about y equals 2x minus 5? What type of graph is that? What is y equals 2x minus 5? What form is that? Wouldn't that? It's a line, yeah. It's slope-intercept form of a line. This is now just in function form. So this is called a linear function, we'll call it now, because it's in the form f of x equals mx plus b. Yeah, we can read right off of, if it's in this form, we can read the slope of that line, and we can read the b, which is the y-intercept of that line. Same deal. The m here is 2. And the b is -5, and so that basically tells me what my line graph is going to look like, doesn't it? So if I graph this thing, all right, so the b is the y-intercept. So the y-intercept's -5, so it's going to cross the y-axis at -5. 1, 2, 3, 4, and 5, so -5. We've got ourselves a little y-intercept there. All right, then our slope is 2, and if we interpret that as rise over run, that's 2 over 1. And so I'm going to rise 2 and run 1 from that point, from the y-intercept point. So I'll rise 2 and then run 1, and that puts me at another point. And I could keep doing that, but 2 points is enough to determine, since I know it's a line, it's a linear function, it's a line. There we go. There's our graph. So, and we'll talk about some other types of functions that we will need to recognize here in a second, but a linear function, we already know, hopefully anyway, we recognize that shape, what the graph looks like. So it's now just f of x equals mx plus b, or g of x, or whatever the function name is. All right? Well, what about f of x equals 2x squared minus 4x plus 3? Well, that one's obviously not a line, because it's got the x squared in it. And maybe you know a little more about it, and we'll talk a lot more about these graphs in the future here. But for right now, since I don't know what the shape is, or maybe I'm not aware of what this shape should be, one thing we talked about before was we could use a table to graph this thing. If I'm wanting the graph of this, one option always for graphing is to use a table. We don't know exactly what's going on there as far as shape goes. Yeah, a table always comes in handy. All right, and so here, let's just do a table, x and y values. Now, again, the y values, that's going to be the function values, the f of x values. F of x is y. And so I'm just going to choose my x values here. And let's go with -2 to +2 for my x's. I may need more, but let's see if that will suffice. All right, with me there? All right, so what are the y values, the f of x values that go with those? All right, so this says I need x to be -2, so I'm going to plug in -2. See what I get there. All right, so I square that. That's +4, 2 times +4, that's going to be 8, and then +8, and then +3. Just have to be careful with your signs there. That is 19. Yep. All right, then do the same thing with -1. 2 times -1 squared, -4 times -1, +3. Again, you square the -1, so that's +1. 2 times +1 is 2. -4 times -1, +4, +3, so that's going to give me 11. 9. Sorry. 9. Then the positive ones get easier. 0 gets easier. If you plug in 0, well, x is 0, so those are both are 0.
3 left.
So yeah, you got 3. And then x is 1. Well, it's 2 times 1 minus 4 times 1 plus 3, so you got +1. And then we got 2, so we got 2 times 4, that would be 8. Minus 4 times 2 would be -8. Plus 3, oh, so we're back at 3. Question?
Is the 1 correct?
Is the 1 correct?
Yeah.
Well, that's 5, and then you got -4.
Okay.
I think it's correct.
Yep.
All right. Let me do one more. Let me do 3, just to kind of see progression, because it did start, but coming back around. But if I do 3, that's 3 squared, that's 9. 2 times 9 is 18. Minus 12 plus 3. And so we're back to 9 there, I believe. Those look right? Everybody believe those? Good with that? All right. All right, so let's graph this. You got x is -2, and then you got y is 19. All right, so let's go back to 2, 4, 6, 8, 10, 12, 14, 16, 18. I think I got it. All right, so -2, 19. All right. And then -1, I'm at 9. 0, I'm at 3. X is 0, y is 3. X is 1, y is 1. X is 2, y is back to 3. I think we can see what's happening. That's why I did the other 3, and then goes back to 9. So it's going back up, isn't it? Yeah, it's going to keep those going both sides. So yeah, if we don't know what a graph looks like, the table comes in handy, can help us out. So that's how in a few minutes we'll do some more graphing of those types of things. Now, well, I've got both of these up here. Any questions on that? Is that okay? Good with that? All right. Well, I've got both of these up here. There is a test to determine if the graph you've got is a function. If you don't know it's a function, of course we already know these both are functions, but both of these pass what's known as the vertical line test. The vertical line test tests a graph, if you will, to see if it's a function, if y is a function of x. It's called the vertical line test. I'll write more about it in just a second, but here's how it works, and I just wanted to show you on these that these do pass the so-called vertical line test. If you draw vertical lines through your graph, you just keep thinking. You don't have to draw necessarily very many, but we're thinking about vertical lines that go through these graphs. In both cases, we see that any vertical line that we draw, one's not the best vertical line ever, but any vertical line we draw on these graphs here, which we know these are graphs of functions, Any vertical line we draw on these graphs will hit the graph only in one point. Each vertical line here hits the graph in only one point. It intersects it in one point. So that's how you determine if a graph is a function, the graph of a function. If it hits more than one, it's not going to be a function. So these obviously pass the vertical line test. So that's what we're going to talk about here next, is that vertical line test. So yeah, let me just write it up here. If the graph passes vertical line test, it's a function. It's the graph of a function. Now, what does it mean to pass it? So, if the graph passes vertical line test, it is the graph of a function. All right, so it passes, the way it passes the vertical line test is any vertical line intersects the graph in only one place, and at most one place, let's say it that way. Any vertical line intersects the graph in at most one point. It can not intersect the graph at all, the vertical line, but it can intersect it in at most one point. So it fails if it strikes the graph in more than one point. So let's talk about a couple of examples here. Maybe some we haven't seen yet. Maybe we have seen them, but we didn't talk about them in function form here. So the question is, all right, so we've got this graph. We don't know the equation, so we can't exactly use what we were talking about earlier on the definition. Yeah, so we're just going to try the vertical line test here. Does this pass the vertical line test? Well, if we think about drawing, you think so?
Yes.
If we think about drawing vertical lines through that graph, you don't have to draw necessarily, but we're thinking here, yeah, we're just drawing vertical lines, and is there any vertical line that I can draw that would hit it more than one place? No, I don't think so, yeah. Any vertical line we draw is just going to hit it in that one point. So yes, this is a function. It passes the one explanation there, passes the vertical line test. Okay? So that one is positive there. All right, what about this one? That one a function?
No.
Nope. Why not?
It
It doesn't pass vertical line test, yeah. If I draw just about anywhere, if I draw a vertical line on this side anyway, yeah, I've got a problem there, don't I? Because this one vertical line hits it in two places. So that's a failing grade there on vertical line test. Now, this is a good one to show you why is this a vertical line test a test for functions? Well, it does go back to the definition of function. Remember, to be a function, 1x goes to what? 1y. Well, look at this x value right here. I don't know what it is, but let's call it -2. Let's say that's our x value, -2, right? Doesn't that x value, -2, go to this y value? Well, let's call it -3. And then it goes to this y value, let's call it 5. So this 1x value it goes with 2 y values. And so that's why the vertical line test works, because it tells you you got 1x and it's going to 2 y's. One more here. So is this one a function? It's got 2 pieces. Your functions could have more than one piece. Is this one okay?
Yes.
It's okay, yeah. In the middle, vertical lines in the middle wouldn't hit the graph at all, right? But that's okay. It can hit it in 0 places. It just can't hit it in 2 or more, right? But any other vertical lines I draw, we're okay. So yeah, that one passes. All right? Any questions on that?